Hi everyone, I apologize. I'm gonna hide my face today. I'm just fighting off a cold. So what I'm gonna do in this video is go over radicals using this workbook here. Okay, as per this comment here goes our lesson on radicals and exponents. So the first thing they want us to do is to label the parts of a radical. So we can see here we've got a couple of things. The first thing is going to be that small little number. That's going to be called our index. And then we've got what I think was always taught to us as the square root, but it really has other functions than just a square. So this is called our radical symbol. And then that large number is the radicand. And then the whole thing is called a radical. Okay, so then the next thing that we might look at is, well, okay, if this one here had a 3, what happens when there is no number? So what happens for that is really there is an invisible 2 here. So that's why, for example, if we said the square root of 9, what we're really saying is 2, indicating that there are 2 numbers that are the same that multiply to that 9. Okay, so the next question says, what is the difference between an entire radical and a mixed radical? Well, it's really quite simple. An entire radical basically is no coefficient. So it would look something like this. Just kind of what we're used to seeing. Now, a mixed radical, it has a number in front of it, or a coefficient. So an example for that would be something like this. All right, for our next question, is it possible to write a radical without the radical symbol? Yeah, it is. And basically the way that's going to be is going to be using fractional exponents. And we'll get to that in a minute, but as an example, we could say something like this. That is still a radical without the radical symbol, but the exponent is a fraction. Okay, so what we're going to do in this one is we are going to convert the entire radical into a mixed radical. So there's 2 ways to do it, the prime factorization method and the square method, and the perfect square method, sorry. So let's say we're looking at our example of root 20. If we're looking at the prime factorization method, what we're trying to do is find all the factors that equal to the square root of 20. So really what we can do is just think about the numbers that multiply to 20 and then pop on that square root on top of it. So the first set of numbers that I know that multiply to 20 are going to be 10 and 2. 2 cannot be broken down any further, but this square root of 10 definitely can. So I can break that down into the square root of 5 and then the square root of 2. So now what this means is I can start to put them together to become my mixed radical. So what this leaves me with is these factors here. And we're going to be multiplying them together. So I want us to think about it. We're going to say root 2 times root 2 times root 5. So what happens is this root times root 2, or root 2 times root 2, they actually multiply to make our whole number, which is just going to be 2. So the answer to this becomes 2 times root 5. Now, just so I'm clear, the reason this works is because when you have any square root number, so I'm going to use a perfect square, just an example that we're really familiar with. So if I say I've got root 9 and I'm multiplying it by root 9, well, we know that those are perfect squares equaling to 3 times 3. Well, 3 times 3 we know is 9. So as a shortcut, we can say whenever we're multiplying 2 roots of the same number, we get the number that's inside the square root. Okay, let's look at our perfect square method. So this is the method that I kind of prefer because I find that it's less steps. So what we're going to do is we're going to look at 2 numbers that multiply to root 20 and one of them is a perfect square. So what I'm going to do is in the description below, I have my list of perfect squares. I'm also just going to flash it right here for a quick second. So let's see, what are our numbers that multiply to root 20? Well, I know that for one of them to be a perfect square, I can use root 4, and then I'm going to multiply that by root 5. So all I've done here is broken down the square root into two factors. I have not changed the value of this. So we can evaluate this. We know the square root of 4 is going to be 2. Square root of 5 is not a perfect square, so it's just going to equal to the square root of 5. And so now we can see we have the same answer. Now let me show you what this looks like on a calculator just to further help with the understanding. Okay, so let's look at this. So I have the square root of 20, and we can see its value. So I'm just going to write it in the corner here, just underneath this example for right now. 4.47, let's go 21. That's the value of the square root of 20, not a perfect square. Now let's say I type in my value of my mixed radical. So 2 root 5. Well, just as we predicted, or maybe we didn't predict, but as we can see here, it's the exact same value. So when we're converting between our square roots and our mixed radical or our mixed and entire radical, the value should always be the same. Okay, so let's look at the prime factorization of the square root of 32. So just like last time, we're going to decide on two numbers that multiply to 32. So I'm gonna go 4 and 8. So we know that this can be broken down into 2. It's just a perfect square. And then the factors of root 8 would be 2 times root 4 actually. So again, we can kind of get a breakdown of this. My root 4 is going to become root 2. It's going to become 2, sorry. So now I can multiply these numbers. So 2 times 2 is 4 root 2. So that would be the answer for that one. Now let's try it with the perfect square method. Although this one does have quite a bit of perfect squares. So I'm sure there's another way you can factorize this. So long as you get the same answer, you're going to be okay. So looking at the perfect square method, I know that there is the perfect square of 16 times root 2. Square root of 16 is going to be 4 times our leftover, which is root 2, and we can see we get the same answer. Okay, let's look at cube roots. So cube roots are a little bit different. What cube roots are saying is you have 3 numbers that are the exact same that multiply to this number here. So it's the same exact kind of scenario, but what we're gonna do is we're going to use our perfect cubes. So let's say I'm looking at the same example they've given me here. First thing I'm gonna do is look at this perfect cube chart to help me, or right now we can just think of the factors. So I have cube root 4 times cube root 4, we know is equal to cube root 16. Now each of these I can break down into cube root 2 times cube root 2. And then same thing with this. Now the difference between what we were doing up here and here is this time, like I said, it's 3 numbers that multiply to the same thing. So then what we can do is take our 3 cube roots and they can become one type of radical. So just like we did last time when we said 2 square roots that are of the same number will give us the same value, in this case, we're just looking for 3. So we're gonna go ahead and get this whole value that I've got highlighted becoming 2 times the cube root 2 that was left over from this spot here. So our answer for this one is going to be 2 cube root 2. Okay, now for the perfect cube method, it's really the same idea, it just happens to work out the same, is I know that I'm looking for roughly 3 numbers that multiply to 16. So for something like this, I know that I can go 2 times 2, well that's gonna be 4, times that by 2 is gonna be 8, times that by 2 again is going to give me the 16 I'm looking for. Now it's a cube root, so I just need to group 3 of these. That's gonna give me 2 on the outside plus the remaining leftover of cube root 2. So as we can see with both of these, we're getting the exact same answer. Okay, so let's look at this example. I'm not going to do all of them, I'm just going to do a few of them. But what we want to do is convert each entire radical into a mixed radical. Now, keep in mind your method can be different than mine, so long as I've said before, we get the same answer. So if we're looking for the square root of 24, we want to convert that into a mixed radical. Well, I'm going to go ahead and I'm going to look at two factors that multiply to 24, and one of them is a perfect square. So that's going to be, for me, 4 times 6. We know the square root of 4 is 2 times root 6. Root 6 can actually be just be kept the same as that, because we can't break that down any further into a perfect square. So our answer for this is 2 root 6. Okay, square root of 72, same idea. I know that if I think of 72, I'm thinking of the 9 times table. So I'm going to say root 9 times root 8. That's the same value, these two numbers, multiply to 72. Take the square root of 9, that's going to give me 3. Bring down what's left because square root of 8 is not a perfect square, and that leaves me with my answer right there. All right, square root of 49, well, we can just use our perfect squares for this one. This one would just be 7, nice and easy. Okay, so the cube root of 64, that one is just like a perfect cube, so that one will just be reduced to 4. Okay, let's look at this one here. So this is looking at the fourth root. So if we're unsure of the fourth roots, we can always search them up, or you can use your calculator to get the total. So here are the fourth roots. And now what I want to do is I want to pull out the factors where one of them is going to be part of those fourth roots, and the other one can be any other number. And the reason I want one of them to be a fourth root is because I can then evaluate it. So if we're looking at something like this, one of the things I do know is 16 times 3 will equal to 48. Well, we know the fourth root of 16 does get evaluated into a whole number. That gets evaluated to 2. And then our fourth root of 3, well, that's just going to stay on its own. Sorry, fourth root of 3. So our answer becomes this right here. All right, so what I'm going to do is I'm actually going to jump ahead from the comparisons and just show you a method that works really well to help convert the mixed radicals into an entire radical. So what we want to do is we need to be clear that we know our index number is a 2. And we know that because, like I said earlier, it's kind of like a hidden number, if you will. So with that 2, what we're going to do is we're going to do this in the reverse order and add the 2 to the 4, because really that's how we got that to begin with. So that becomes 16 times 2. Now everything is still under a root, so we can almost imagine it like this, and then that's going to become the square root of 32. Okay, same idea with this one. We're going to imagine our invisible 2 here. So that becomes 5 squared root 3. 5 squared is going to be 25 times the 3, but everything is under the same root, so that becomes root 75. And one thing I didn't do is why don't we compare it with a calculator and make sure we're getting the exact same answer. Okay, so here's the calculator just to compare it. So I'm going to go 5 times root 3, and we can see that's getting me something close to about 8.66. And then we're going to go ahead and do the same thing with our root 75. And you can see we got literally the same thing. So again, when you're working on this on your own, you can always check your answers with a calculator to make sure that they're the same. Okay, we're gonna do the same thing here. So I'm gonna go 3, and this time it's not invisible, so 3 to the power of 3 times root 3. So we can figure that out. So really we're saying 3 times 3 times 3, that's gonna become 27. And we know that that's under the cube root of times 3. So then we can go ahead and multiply those. So that's going to get me cube root 81. Okay, what I'm going to do is ask you to pause it here, try this one, and then I will show you the answer. Okay, the answer for this is fourth root 48. All right, in the interest of time and my voice, what I'm going to do is I'm going to get you all to do this. My key thing with this is to go ahead and you can evaluate them and pop them on the number line, or if you like, you could use a calculator and then pop them on the number line. Okay, so let's go try this one here. So remember we have our invisible 2. So that's going to become 4 times root 12. Now all of that is raised over 4. So that means our 4s are going to cancel out. Now remember, it is this times that and this times this. So we want to treat them as 2 different multiples upstairs, if you will. So the 4 over the 4 will just reduce to 1, so that's fine. We don't need to worry about that. Then our next part is our 12 over 4. 12 over 4 is going to divide into 3, so our answer for this one is just going to be root 3. Okay, so for B, we're going to say we have 27 over root 27. Now we know that the cube root of 27 ends up becoming 3, so this becomes 3 times 3. Over that 36, now that 36, I am just getting it from this here, just bringing it down here. That leaves us with 9 over 36. Now we can go ahead and reduce that fraction. So that's going to be reduced to 1 over 4, and that's our answer. Okay, let me know in the comments if you have any questions about this one, because I do see why this can be tricky, but I'm going to do my best to break it down. So the first thing I'm going to do is I'm going to just kind of leave the 3 over 4 on the side over here. We're going to come back to that, but for now we're just going to ignore it. Now what I want to do is I want to go back and turn this into a mixed radical. And the reason I want to do that is because if any of them end up with a 4, I know I can cancel that out and therefore remove my fraction. So let's go ahead and let's look at our perfect square method. So if I'm looking at the root of 32, I know that can be used by or found by root 4 times root 8. Now I also know if I were to continue to factorize that, I would get root 2 over root 4. So my factors are these numbers here that when multiply to root 32. Now 2 of these I can reduce. So my square root 4, I'll actually just rewrite everything right here so we can see what's happening. So all I did was I just took these, wrote them here, and again, I'm ignoring this for right now. I will tack it back on as we move forward. So now we're looking at root 4, which just becomes 2, and again, root 4, which also becomes 2. So we know 2 times 2 is going to make 4 once I evaluate it, and now they're no longer going to have their square roots. So this now becomes 4 root 2. This is the breakdown of this here. Now let's go ahead and let's bring back my fraction. We'll just use that little dot to indicate multiplication. So just to recap, I haven't changed anything other than just converting this into a mixed radical. Now let's bring back the fraction and let's see what we can simplify. So the first thing I notice is I have a 4 on the top of the fraction. I can even extend this if that makes it easier to see. We've got a 4 on the top and a 4 on the bottom. Well, those are going to go to 1, leaving us with our final answer of 3 root 2. Okay, example D, this one's kind of nice. So basically we're saying both of these numbers are under a square root, and these are both perfect squares. So this one is going to simplify really nicely to just 7 over 9. Okay, so let's look at this example here. What I'm going to do is ask you to pause it, try it on your own, and then we can go over it together. All right, so let's go ahead and let's look at this one. So we have to do our little bit of a reverse. So 2 things I'm gonna do is let's separate our top and our bottom. So I know my bottom is a perfect square here. So I'm just gonna leave that, as we know the answer for the bottom is going to be 8. That's already simplified. Now let's look at our top. We know we have 3 root 3 because I need to pull that index out. So 3 root 3 is going to give me 27 over 8. And then now we have to deal with the cube root of 72. So what I'm going to do is, before I even tackle that, I'm going to write down the factors of 72. Now I'm going to use a factor tree just because I find that that's the easiest way that my brain likes to visualize it. So the first thing I'm going to say is, okay, well, what are some factors of it? I know 2 times 36 multiplied to 72. I can break down that 36 into 6 times 6. And since we're not dealing with perfect squares, but a cube, I have to keep going until I get 3 numbers that are the same to help simplify. But also this 6 isn't broken down into its smallest form. So 2 numbers that also multiply to 6 are these here. Now if I look at it, I can see that I've got 3 numbers that are consistently repeating. So that means I can pull out a 2 as a cube root here. So this is going to leave me with the cube root of 72, just the cube root, as 2 cube root 3 times 3. That's going to simplify to 2 cube root 9. All right, now let's bring back in everything we've got up here. Oh, I forgot something up here. This should have been the cube root of 27, which makes that, sorry, I totally forgot, which is going to make that equal 3. So now let's bring up everything that I've got up here. Let's bring it down here. So that means I need to bring down that 3 that I just evaluated over the 8 that's on the bottom there. Now this is going to simplify to 6. Cube root 9 is going to stay the same. We can't simplify that further, over 8. Now at this level, we want to make sure every time we see a fraction, we go ahead and reduce. So 6 over 8, they're both even fractions. I can divide them by 2. That's going to get me to 3 over 4, and then the cube root of 9. So here is our final answer. Okay, I'm going to end this video here. Please go ahead and click for part 2.